Hey everyone, let's look at the number 25 in section 4.3. I think it's the last one. And you have a function similar to this one here. And you're asked to find critical points, identify which critical points give rise to your local max or local mins, and then find the intervals where you're increasing or decreasing. This function just rewritten right in without the negative exponents looks like this. And you can see we have a problem when x is 0. Division by 0 would result in an undefined expression. And so the domain of our function, right, is all real numbers except for 0. In fact, if you analyze what's going on with limits, you know that we have a vertical asymptote at x equal 0. We could actually simplify this function a little bit by writing it over a common denominator. In other words, 1 divided by x squared minus 11 over x is 1 over x squared minus 11x over x squared, multiplying top and bottom by x. So it's 1 minus 11x over x squared. I'm not suggesting necessarily that you rewrite it in that form to find the derivative, which we're going to need to do in a second, but that's what this function is the same thing. And you can see again clearly that when x is 0, we've got a problem. So there's a vertical asymptote there at x equals 0, and that's going to come into play when we do a sign check of our derivative. We want to include the fact that we could have a sign change across, right, a vertical asymptote. So for instance, if this is if this is the x-axis and we have a vertical asymptote here at a particular point, then the function maybe on this side is approaching positive infinity and it's always above the x-axis. In this case, going to negative infinity, always below, as we have a sign change, right? On this to the left of the vertical asymptote, the function is positive, and on the right it's negative. So you can have a sign change, and that's important to check that value. So, all right, I'm just going to use this form though to find the derivative. Power rule, right? Bring the -2 down. Subtract 1 from -2 gives me -3. Bring the -1 down. Negative times a -11 is +11. Subtract 1 from -1 gives me -2. Here's the derivative. I would like to go ahead and factor out a -1 and then x to what power? Well, a smaller power, I'm going to fill out the -3. So I'm going to factor out -x to the -3, which leaves me +2, right? Because it's minus times 2 gives me that -2. Of course, I've pulled out the x to the -3. And then here, notice it's minus, so I factored out a negative, so it's -11. And then what needs to be left over if I factor out a negative x to the -3 from x to the -2? Well, remember, when we multiply these together, we're going to add the exponents. -3 plus what gives you -2, and the answer is 1. And so this is the factored form, which I can rewrite, right? X to the -3rd power right here. This is the same as 1 divided by x cubed. And so I get negative the quantity 2 minus 11x divided by x cubed. If I distribute this -2 through, it becomes -2 plus 11x or 11x minus 2. So just in that nicer form, there's my derivative. Now, again, x can't be 0. We know that's not in the domain, but and therefore the derivative is never undefined on the domain of the function. But it is equal to 0 when 11x minus 2 is 0, right? When the numerator is 0, and that occurs when x is 2/11. That, in fact, is the critical point. And so we only have one. And so we need to do a sign check now on our derivative. And here's how I've done it. Notice I've got my 2/11 here where the derivative is 0. I'm also going to include 0, and I put a u there. I put a u there for undefined. You could put, maybe VA for vertical asymptote if you want to, or something, because that's really what's going on. But the function is not defined there. We have some kind of vertical asymptote, and we could potentially have a change in sign there. So we need to check on either side of those vertical asymptotes. Okay. So now we just check the sign of the derivative. Remember, this is our derivative here in each of these three intervals. So something less than 0, I try -1. If I plug -1 in for x, I get -11 minus 2 over -1 cubed, which is -1. That's a +13. So everything's positive there. Between 0 and 2/11, I choose halfway between 1/11. Okay, so I plug in 1/11 into the function. 11 times 1/11 is 1 minus 2. I get -1 divided by 1/11 cubed, which becomes -1. number, right? Well, negative 11 cubed is what it becomes. So it's still negative, less than 0. So everything in between there is going to be negative, everything between 0 and 2/11. And then greater than 2/11, I'll try 1. F prime of 1, if I plug in 1, is 11 minus 2, which is 9, divided by 1 cubed, which is 1, which gives me 9, which is positive, more importantly. Okay, notice at 2/11, we have a sign change from negative to positive, meaning decreasing to increasing for the function. And so therefore we have a local min, right, at 2/11. So that critical value 2/11 gives, it corresponds to a local min. Positive to negative, someone might say, hey, we got a change in sign, so we have a local max at 0. No, we don't. The function's not defined at 0. There is no local max there. In fact, what we have is a vertical asymptote, and it's the functions, the derivative is positive. The function's increasing what? Going to infinity because we're approaching this vertical asymptote, and decreasing here means it's coming down from positive infinity. So what's actually happening here for this one, unlike what I've drawn here, right at 0, we have this, this is the y-axis right at 0, but we have a vertical asymptote at 0, and so it's increasing as we approach there. So we're going up to positive infinity, and it's decreasing, right, going down this way. So this is what the graph looks like close to the y-axis for the function, the original function f, right, based on the sign of the derivative. Okay, so we don't have a local max. We do have a local min at x equal 2/11, and then we're increasing where the derivative is positive. That's everything less than 0 and everything greater than 2/11, and we're decreasing where the derivative is negative between 0 and 2/11. Okay, this is the key, though. You have to show a sign check on that derivative for support on a test, so make sure you do that. You should be doing that with your homework, and that's what I'll be looking for. Okay, hope this helps on this one.